Welcome to my tutorial on dynamically allocated lists in C. So we're gonna implement a struct and a set of functions that work similar to C++'s vector. For this example, I'm just gonna have it work with integers, but you can modify it to work with whatever type you want, even a custom type with like void pointers. But for simplicity, I'm gonna stick with ints. So we're gonna have three files: lib.h, lib.c, test.c. In lib.h, we'll have a nice interface to work with some descriptions. In lib.c, we'll actually implement the vector, and in test.c, we'll test it all out. Now, if you want to, you can do this all in one file, but I think it looks nicer this way. First, into the library. Oh, actually, if not def. Okay, so this will make sure it's only included once, so no weird errors. So we're gonna include this, and we're gonna use some booleans, so that too. Okay, so type def struct. So we'll have an int pointer that'll work like a list elements. We'll have a bool pointer init list. This will keep track of what elements are initialized and which ones aren't. Then we'll have length and size. So size will keep track of like, how am I getting this error? Expected identifier. Oh yeah. So size will keep track of how many like elements we have space for in memory, and length will keep track of the highest accessed index. So we'll know when to resize it. So we'll have a couple functions. First we'll have this vector new. Oh yeah, I'm gonna be putting the vector word first so that when I use IntelliSense, it'll like, after I type vector, it'll suggest all these functions. It's just a little easier. We'll have, or actually, it should be int vector get. So we'll accept a vector pointer, index, and value. That should be set actually. Similarly for vector get, just take out the value, and vector set should return void. Okay, so comments, I'll just add a simple description. Actually, we'll have a small helper function. Bool vector exists. So reads and okay, so let's start by implementing vector new. So in lib.c, include lib.h. Yep, okay. So we'll create a vector pointer from malloc size of vector. And we'll also cast it to vector pointer explicitly because it returns a void pointer. Okay, so v elements will be int pointer, an int pointer, size of int times 5. So we'll just start with 5 empty elements. Similar for init list. We'll replace int with bool. Then we have to set it all to false, so for int I equals 0, I is less than 5, I plus plus. Init list v init list I is equal to false. Then v dot size is 5, v dot length is 0, return v. Okay, so that's our vector new function. Just creates a bunch of empty elements. Vector set. The reason I'm using unsigned integer for index is firstly it can go higher, and I don't feel like doing bounds checking like greater than size for all the functions. Well, we do have to do greater than size, but we don't have to do like less than 0 bounds checking because unsigned integers cannot be a negative. So if if index is greater or equal to v dot size, or v dot length is greater or equal to v size, and we'll have a bool resized is equal to false. V size times equals 2, resized equals true. Okay, so this will just resize it as necessary. Change this from an if to a while, because what if we need to resize it multiple times, like the index is really big. Anyways, so if resized, then v elements is equal to int pointer again, realloc, because we're not creating a new block of memory, we're just expanding this one. Pass in v dot elements as the block and v size as the size, or v dot size times size of int. Then same thing for init list. Okay, so we need to fill init list with false again. So while I is less than size, and I will start at v length plus 1. So this will set all the new spaces to false. Then v index equal to actually v contents elements index is equal to val, and v dot init list dot index is equal to true. We don't return anything. Is that all? Oh, you have to keep track of length. So if index greater than v length is equal to index. So that's our set function. So this is really all the dynamic part. It makes sure you never run out of space. The reason why we don't have like a vector size function is because you can just do vector size with this like element. So alright, so for get, we'll say if vector if index is greater or equal because index's start is 0. Size fprintf, we can include standard input output. Okay, so fprintf to standard error, index out of bounds, so we won't terminate the program, but we will print an error. Then if vector, if not vector init list at index, so it's not initialized, copy this, uninitialized element accessed. Okay, then we can say return v elements at index. Last function's pretty straightforward. Vector exists. So if index is greater or equal to v size, return false, return v init list index. The reason why we can't just do this is because C will complain out of bounds. Alright, now let's test it. Include lib.h. So I'll make a nice main function. So we will have vector v x. We'll make an int array called x. Set it to 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so v is equal to vector new. You can see that nice description there from the .h file. So for int I equals 0, I is less than 10, I plus plus, vector set v at I to x at I. The reason why I'm not including the standard library again, because I've included this .h file, and because it includes the libraries, we don't need to double include them. So same thing, except this time we're gonna do printf %d for integer, vector get v at I. Then we're gonna do one last thing. So a boolean is an integer, so %d will work. It'll say 0 if it's false and 1 if it's true. Okay, so vector exists v 11 or 10 actually, that should return false. So let's compile it with gcc lib.h lib.c test.c -o test.exe. Let's try it out. Yep, it works. And you can see it says 0. Yes, it's false because that doesn't exist. If you want to replace it with vector get, it should give an error. Yep, index out of bounds. Alright, thanks for watching my tutorial on dynamically allocated lists in C, and goodbye.